Hello everyone, this is Reshma from Edureka, and today's video is on Hadoop Project tutorial. So in this video, I will be demonstrating you a very interesting project so that you can learn more about Hadoop and also practice it along. I must also tell you that this project is also a part of the Big Data Hadoop training at Edureka. So let's get started. So this project is based on the e-commerce domain. So let me give you an introduction to this project in context of one of the biggest names of e-commerce platforms, none other than Amazon. So if you have ever shopped from Amazon before, which I presume you must have seen something like this when you click on a product. So you'll view the details of the product, something like this. And as you know, most of the e-commerce organizations do not have any inventory, so they tie up with different merchants. Similar is the case with Amazon. Amazon provides the merchants or the sellers a platform to get connected to the buyers. So when you click on the details of a product, you can see that Amazon gives you something like this. And you also find something like this. There are 28 offers from this price. And if you click on it, you can see the name of the different sellers who are selling the same product at different prices. And the prices they're offering are listed like this. But you can see over here that by default, Amazon has selected the Apparel Retail Private Limited for this particular product. So how does Amazon do that? So it is actually based on a merchant rating system. And as a platform, as an e-commerce platform, you have to ensure that you always display the product from the best merchant in order to ensure quality, because you don't want angry customers, right? So it is very important that your customers are satisfied with their product. So you have to choose from different merchants for the same product in order to decide which merchant's product needs to get displayed by default. And hence Amazon has a merchant rating system in order to decide that. And this is what exactly we're going to build. All right, so we're going to make a merchant rating system similar to this. So here is the problem statement. So there are multiple merchants selling the same type of products. As you can see that merchant 1 and merchant 6 are selling the same shirt, merchant 3 and 4 are selling the same shoes, and similarly 5 and 1 are selling the same pants, and there are multiple other merchants who are selling the same kind of products. And you have to build a merchant rating system, or the company wants to build a merchant rating system in order to determine which merchant sells the best product, so that their product would be displayed by default. And as a big data expert, let's just assume that you are hired by the company as a big data expert, you are assigned this task. So this is now your problem to solve. So the first thing your organization will give you before you start to do your work is the data set. So this is the data set that you're going to get. So this is the transaction data set, and has certain fields like transaction ID, customer ID, merchant ID, timestamp when the purchase was made, the invoice number, the amount, and the segment of product that was bought. You have another data set, which is the merchant data. So these are the details about the different sellers or the merchants. So you have got your merchant ID, the tax registration number, the merchant name, their mobile number, start date, email, address, state, country, PIN code, description, longitude, latitude, the location basically. So these are all the details about the merchant that you have in your data set. So let me just show you the data set. So this is the data set that is in your HDFS right now. So here is the transaction data. So here is the transaction data, which is a 2 GB of file, and the merchant data set, which is 20 MB, because as you know, there are many transactions, but a limited number of sellers or merchants. So that is why the size of the data set, the merchant data set, is quite smaller as compared to the transaction one. And to tell you, we haven't actually used the entire data present in the data set. We have just selected a subset or a sub data set, you can say, because the original data set was quite huge. And this was a demo project. So just for your understanding, we have chosen a sub data set. We just took 2 GBs of data out of it. All right. And this is how it exactly looks like. So this is the CSV file of the data set that we have. This is the transactions data. All right. So this is the approach to solve. So the first thing we'll do is that we'll segregate the merchants based on the price of their products and their sales. So we will be segregating them into 4 categories. So the categories are the merchants who are selling products that are below $5,000 or less than $5,000. There is one more category for merchants who sells products between $5,000 to $10,000. Another category of merchants who sells products between $10,000 to $20,000, and another category greater than $20,000 or more than $20,000. We'll be using a simple logic to approach solving this problem. So let's say that if there is a merchant who's selling their products at quite a low price, and you see if he's not making a good number of sales, it means that he is not selling quality products, because if a merchant who's selling the product at quite a less price and people aren't still buying from him, it clearly indicates that his products are not up to the mark. So it's a low rating for a merchant. Similarly, on the other hand, if you see a merchant who is selling their product at quite a high price and yet he has a very good number of sales, so it clearly indicates that his products must be very good, because despite of the higher price, people are still buying from him. So in that case, obviously the rating of the merchant would be also very good. Right? So this is a simple logic that we're going to use in order to rate our merchants or sellers. And you have 3 options to choose from. So you have got Apache Hive, which is a great analytical tool. We have got Hadoop MapReduce and Apache Pig. And today we will be choosing Hadoop MapReduce. So MapReduce is the core component of Hadoop that processes huge amount of data in parallel by dividing the work into a set of independent tasks. MapReduce is the data processing layer of Hadoop. It is a software framework for easily writing applications that processes the vast amount of structured and unstructured data that is stored in your HDFS. HDFS is Hadoop Distributed File System. In Hadoop, MapReduce works by breaking the data processing into 2 phases, map phase and the reduce phase, and that is how exactly it gets its name, MapReduce. So the map is the first phase of processing where we specify all the complex logic business rules. Reduce is the second phase of processing where we specify lightweight processing like aggregation or summing up the outputs. But the question is, why choose MapReduce? Well, I'll give you 2 reasons for it. First is the custom input format. Now, input format is something that defines how your input files are going to be split and read. So in MapReduce, you can create your own custom input format instead of using the default input format. This actually makes handling of your data quite easier, because here we can create our custom input format for transactions and pass it as an argument. Then we have the distributed cache. So distributed cache is nothing but it is a facility that is provided by MapReduce framework to cache files. Files like your text files, archives, jars, etc. that is needed by your application. Let's understand this with an analogy. Just think about it that there are 3 students sitting on a table solving chemistry problems, and they have one periodic table. So you keep the periodic table in the middle of the table so the students, all the 3 students, can refer from the periodic table to see the atomic numbers of different elements and solve their problems, right? So one periodic table, everyone can refer to it and solve their own problems. So this is what distributed cache is. So with distributed cache, you can put the data that will be used by your different data nodes to refer in order to run MapReduce jobs. So we'll be learning more about how to create your custom input format and how to use the distributed cache in the demo part. All right. So before that, let us just understand how MapReduce exactly works. So this is a sample MapReduce job execution with an example. So this is your input file. This is a text input file. So it contains some words. So first, what will happen is that the input will get divided into 3 splits. All right, so I'm taking one sentence at a time. So I have got 3 splits over here, and this will distribute the work among all the different map nodes. Then we will tokenize the words in each of the mapper and give value 1 to each of the tokens or words. So deer 1, bear 1, river 1. Similarly here, car 1, river 1. And now a list of key value pair will be created where the key is nothing but the individual word and the value is 1. So this is the key and this is the value. And this will happen on all the 3 nodes. So the mapping process remains same on all the nodes. So after the mapper phase, a partition process takes place where the sorting and shuffling happens. Here all the tuples with the same key are sent to the corresponding reducer. So all the bear are together, cars are together, deer and river are together. So after the sorting and shuffling phase, each reducer will have a unique key and a list of corresponding values to that key. For example, bear 1, 1, car 1, 1, and so on. Now comes the reducing phase. Now each reducer counts the values which are present in the list of values. So reducer gets a list of values which is 1, 1 for the key bear, and then it counts the number of ones in the list and gives the final output as bear 2. Similarly for car, it's 3, deer 2, river, it will count 2 ones, so 2. And finally, all the output, the key value pairs are then collected and written in the output files. So this is your output file. So it has just combined the result from different reducers, and here is your final output. So I've understood MapReduce with the classic example of the word count program. Now this is the generic execution flow of the MapReduce job. So you have your input file over here. So the data for MapReduce task is stored in input files, and input files typically lives in the HDFS. The format of these files is arbitrary, while line-based log files and binary format can also be used. And you have an input format. Now input format defines how these input files are split and read. It selects the files or other objects that are used for input, and input format creates the input split. So it logically represents the data which will be processed by an individual mapper. One map task is created for each split, and thus the number of map tasks will be equal to the number of input splits. The splits are then divided into records, and each record will be processed by the mapper. Now let's talk about the mapper. So mapper processes each input record from the record reader and generates a key value pair. And this key value pair is generated by the mapper is completely different from the input pair. The output of the mapper is also known as the intermediate output, which is written to the local disk. The output of the mapper is not stored on HDFS as this is temporary data, and writing on HDFS will create unnecessary copies. So then the mapper's output is passed on to the combiner for further process. The combiner is also known as the mini reducer. So Hadoop MapReduce Combiner performs local aggregation on mapper's output, which helps to minimize the data transfer between mapper and the reducer. Once the combiner functionality is executed, the output is then passed to the partitioner for further work. Now, partitioner comes on the picture if you're working on more than one reducer. And here we have 2 reducers in the example. So if you have one reducer, you don't actually need a partitioner. So the partitioner takes the output from the combiners and performs partitioning. Partitioning of output takes place on the basis of the key and then sorted. So by hash function, a key is used to derive the partition. According to the key value in MapReduce, each combiner output is partitioned, and a record having the same key value goes to the same partition, and then each partition is sent to a reducer. So by using partitioner, it allows to have an even distribution of the map output over the reducer. So after that comes the shuffling and sorting part. So now the output is shuffled to the reduce node. The shuffling is the physical movement of the data which is done over the network. Once all the mappers are finished and their output is shuffled on the reducer nodes, then this intermediate output is merged and sorted, which is then provided as an input to the reduce phase. Now comes the reducer, so it takes the set of intermediate key value pairs produced by all the mappers as the input and then runs a reducer function on each of them to generate the output. The output of the reducer is the final output, which is stored in HDFS. So if you have multiple reducers, the result from different reducers will combine, and that is going to be your final output, which will be written into the HDFS. So this was the MapReduce job execution flow. So we'll also be using the distributed cache. So you'll have different data nodes. Each data node will have their local copy of their data. And if each of the data nodes needs to refer something, we will keep that in the distributed cache. And in this case, we'll be keeping the merchants file. All right, so distributed cache is nothing but think of it as a shared drive, right? So if you have multiple users who wants to have access to one data set, so you can just put it up in the shared drive and all of your users can share the data, use the same data, right? So this is what distributed cache is. So applications specify the files via URLs to cache via the job conf. So I'll be telling you about the job conf later in the demo section. And the distributed cache assumes that the files specified via URLs are already present on the file system at the path specified by the URL and are accessible by every machine in the cluster. So the framework will copy necessary files to the slave node before any jobs are executed on that node. And distributed cache tracks modification timestamps of the cache files. So clearly the cache files should not be modified by the applications or externally while the job is executing. So how will it work? So in our case, we'll be storing the data into HDFS and we'll be executing MapReduce program over that file. So we'll store the merchant data in the distributed cache. Then we'll segregate the transaction data into categories such as less than $5,000, $5,000 to $10,000, $10,000 to $20,000, and greater than $20,000 with the merchant ID. Then we'll use the merchant file from the distributed cache and map the merchant ID with the merchant name. And at last, we'll receive the output as the merchant name with date indicating the number of sales in different categories. Now let us talk about the code sections. So the execution will start from the main method where we'll use the tool runner. So the tool runner can be used to run classes implementing tool interface. So it passes the generic Hadoop command line arguments and modifies the configuration of the tool. Then it will point to the run method, which will point to the run MR jobs. So here we are specifying the driver code. So I'll be telling you about the driver code later on. So next, the execution will move to the mapper class, which is the transaction mapper. The framework first calls the setup method, followed by the map method for each key value pair in the input split. So in setup method, we are loading the cache file and calling a method where we'll be resolving the merchant name from the merchant ID. Next, in the map method, we are creating the object of transaction, which we will be using to catch all the fields of transaction first, and then using the object of aggregate data, we will create the segment of transactions as we discussed before, the 4 segments, less than 5,000, 10,000, 20,000, those segments. At last, using the merchant ID name map, we will resolve or find out the merchant name. The output of the map method would be the key, which will be the combination of merchant name and date of sale, while the value would be in the form of number of sales of different categories. Next, the execution will go to the partitioner code, where we'll have the get partition method, which will send the records with the same key to the same reducer. And at last, the reducer code will execute, which will aggregate the data with the same key and provide the output. So I'll be showing you and explaining you all the codes involved over here in the demo part, all right? Now let us move ahead. So first, let me take you through this transaction class where we are defining all the variables corresponding to the transaction file. As you can see, we have got the transaction ID, customer ID, merchant ID, timestamp, invoice number, invoice amount, and segment here. So these are the fields in the transactions, and we have created the variable for the same. So next, we are creating the getter and setter methods for each of the variables so as to read the value of the field, and we write the value of the field. So as you can see here, we are defining the method get. So get segment, we have got get segment here where we are returning the value of the field, and the set method here, the set segment, where we're writing the value of this field. So similarly, we're doing it for all the variables as you can see here. So we have the get and set for customer ID. So we have the get customer ID method, which returns the value of the field, and we have got the set customer ID, which writes the value of the field. So this is similar for all the fields in our transaction data. So similarly, you can have the aggregate data class, which we have used to create the categories of the product. So here we have fields like order below 5,000, order below 10,000, order below 20,000, order above 20,000, which are nothing but the different categories which we have defined earlier. And similar to the transaction class, here we are defining the getter and setter method. So we have got get total order method, which returns the value of total order. And we have set total order method, which is writing the value of this field total order. So we have the same for all the different variables that we have defined in the aggregate data class, the getter and setter methods. Then we've got the aggregate writable class. So first here we are creating an object of JSON class. So JSON is basically used to convert Java objects to JSON format. Next, we're initializing the aggregate data object. Now we have two constructors. First one is the basic constructor, which is not taking any argument. The second constructor is taking aggregate data format as an argument and trying to initialize the aggregate data object. Next, we have the getter method for the aggregate data, which will return the aggregate data object. After that, we have the write method, which will write the value of corresponding fields using the getter method of the field. Like for order, get order below 5,000, get order below 10,000, order below 20,000, get order above 20,000. Then you have read fields method, which will be calling the setter method of each field to assign the values to the corresponding field. And at last, we are overriding to string method, which will convert the aggregate data object to JSON and then return the JSON. So I hope you guys are clear with the custom input format. So now let us take a look at the main Java file, which is the merchant analytics job.java. So the main class is the merchant analytics job class, inside which all the jobs will reside. So the execution will start from the main method. So first let us go to the main method. So here we are using tool runner. So tool runner can be used to run classes implementing the tool interface. It passes the generic Hadoop command line arguments and modifies the configuration of the tool. So toolrunner.run method runs the given tool after parsing the given generic arguments. It uses the given configuration or builds one if null. It sets the tool's configuration with the possibly modified version of the conf. Here we are passing the configuration object, merchant analytics job object, which is the main class, and arguments which we will be providing while executing the job. So in our case, there are three arguments. First is the path of the transaction file, second is the path of the merchant file, and third is the output directory. Now we will execute the run method, where we are returning the values of the run mr jobs method. We're also parsing the arguments, that is all the three paths, that is the transaction, merchant, and output directory to the run mr jobs method. Now let us see the run mr jobs method. So here we have the driver code. So first we initialize the configuration object and then we will initialize the control job object. So control job class encapsulates a MapReduce job and its dependency. It monitors the state of the depending jobs and updates the state of this job. And now we are creating the object of job class, and we will define the properties of the job. So first we have the set output key class property, where we are defining the output format class of the key, which is text class. Similarly, we're defining the set output value class for output format class of the value, that is the aggregate writable class. Next, we have set jar by class, which tells the class where all the mapper and reducer code resides, which the merchant analytics job in our case. Now we are specifying the reducer class, which is merchant order reducer. And next we are providing the input directory. So the set input, the recursive method will read all the files from the directories recursively if we are providing the directory path. So first we're adding the input path of the transaction file, which is present in the argument 0. Then here we are also specifying the input format of the file and the mapper class, that is the transaction mapper. Next, we're talking about all the merchant file from the directory provided in argument 1 and adding this file to the distributed cache using the job.addCacheArchive method. And moving ahead, we are setting the output directory path, which is provided in argument 2, and we are also adding the timestamp as the subdirectory. And at last, we are setting the partitioner class, that is the merchant partitioner. And then we are returning 0 or 1 depending on whether the job has been executed successfully or not. And next we will take a look at the transaction mapper class, which implements the mapper interface. So it maps input key value pairs to a set of intermediate key value pairs. So maps are the individual tasks which transform input records into an intermediate record. The transformed intermediate records need not to be of the same type as the input records. The Hadoop MapReduce framework spawns one map task for each input split generated by the input format for the job. And mapper implementations can access the job conf for the job via the job configurable and initialize themselves. The framework first calls the setup method followed by map method for each key value pair in the input split. So in the setup method, we are loading the merchant file from the cache using the getCacheArchives method. Then from each file, we are calling the load merchant ID name in cache. So we're calling this method and we are passing the path of the cache files and the configuration objects. Now in this load merchant ID name in cache method, we are initializing the object of file system using the conf. And next we're opening the file and then we're reading the data line by line from the file. Now here first we're removing the quotes from the line and then we're splitting the line using the comma. And at last we're putting the merchant ID and merchant name in the merchant ID name map variable. So here you can see in the merchant file that we have merchant ID at index 0 and merchant name at index 2. So this merchant ID name map will help us in resolving the merchant name from merchant ID. And next, we're defining exception to notify us if the cache file is not read. And at last, we're closing the object of the buffered reader. Now let's talk about the map function. So now the map function will be called. So the input format of key is long writable and the value is text. We're also creating a context of the mapper framework where we will be writing our intermediate output. Now the output format of the key is text and the value is aggregate writable. Again, here we are removing the quotes from the line and then we're splitting the line using comma. So in the split array, we have all the fields of the transaction data stored in the consecutive indexes. Now we are creating an object of transaction class and setting the values of the field using setter methods. And next we are creating the objects of aggregate data and aggregate writable class. Then using transactions get invoice amount field, we are deciding that in which aggregate data field the transaction would lie. We will set the value of corresponding field of the aggregate data object to 1. And next we have the output key, which will contain the merchant name and the date of sale. We will set the value of corresponding field of that aggregate data object to 1. And next we have the output key, which will contain the merchant name and the date of the sale. So merchant ID name map method will return the merchant name from the merchant ID as we just discussed. So we are passing the values as merchant ID and the date. At last, we'll pass the intermediate result in the form of key and value to the context. Next, the result will be sent to the partitioner class, that is the merchant partitioner. So it's over here. So in this class, we are overriding the default getPartition method. And in this method, we are converting the key using hash function and using abs method to return the absolute value of a number. And at last, we're using the modulo function to get the remainder. And now we're dividing it with the number of partitions, so which is nothing but the number of reducers. And in our case, we have specified 5 reducers, so the modulo 5 would return the value between 0 and 4. And one more thing is, the same key would always have the same hash generated, and hence the modulo result would be also the same. And thus the records with the same key will be sent to the same reducer. And based on this, records are sent to the reducer. So next we have the reducer code, and it's over here. So it's the merchant order reducer. The reducer class, as defined in the driver code, resides in the merchant order reducer class. So here we have the key input as text and value input as aggregate writable, which was written by our mapper class. And the output key format is again text, and the output value format is aggregate writable. So here our execution will move to reduce method, where we are passing the input key, value, and context as argument. And here we are again creating the objects of aggregate data and aggregate writable class. And next we are taking the input values. Now here we are calling the setter function of each category, getting the earlier value of that category, and then adding the new value of the new aggregate data object for that category. So it will add the value to the corresponding fields if there is a record with the same key. And at last, we are writing the key and value in context.write method. So I have explained you the code, so now let us just go ahead and execute it. So first, let us move to the project directory. So we have the pom.xml file, which has all the dependencies that we require in order to run our MapReduce job. So this is the command. So it has my jar file and the path of my jar file. Then I have got my main class over here, which is merchant analytics job. So this is where my main function is. And then I'm passing the 3 paths. So first is my transactions.csv. This is my data set. This is the path of my data set. Then my merchant data. This is the path of my merchant data. And finally, my output directory, which is the result. This is the path over here. So let us just go ahead and execute this command. So the code is run. So here are the different parameters on which this MapReduce job was run. So you can see the details over here. So you can see the number of reduced tasks were 5, since we had 5 reducers. So you can see all the details here. Let me just show you the result now. So it is in the results directory. So there are 2 directories over here, because this was the earlier one that when I had previously executed it. So this is the one that we have got right now. So let me just show it to you. So we have got 5 part files because there are 5 reducers. So I'm just clicking on one part, and you can just click on download. All right, let me just open it. So this is what you get. So you get the merchant name and the timestamp over here, and also the category or the segregation that we did based on the cost of the orders, right? So it was order above $20,000 at this timestamp, and the total order was 1. So this is the format of the result. So we have got a lot of rows. So this is the result. So we have just used a few fields or parameters from the merchant file. We have just used the merchant name and the ID over here. since this is a sample project, sample demo project, but the scope of this particular project is huge. You can use a lot of other parameters that was mentioned there, like the location. You can analyze it based on locations, based on the time period where the order was placed. So you can take in account different fields and improve this or make this analysis even better by yourself. So when you're doing this project as a part of your course curriculum, so you will be exploring the other fields as well. I have just shown you with just using two fields, the merchant name and the ID. All right, but there are many other projects that you can choose from in Edureka, not just that one. So there are different projects related to different domains. So there is one project related to media domain to analyze movie ratings. We have more on social media where you can analyze the YouTube data to identify which are the top 5 categories which gets most number of videos and which are the top rated videos on YouTube. So there is another one related to the aviation industry, the airline data analysis. Then you have got the customer complaint analysis related to the retails. You've got the tourism data related to the tourism industry, banking and finance. You'll be analyzing loans and categorizing it. So there are many other projects related to different domains. You can choose to complete any one of them. And even if you want, you can choose multiple of them. And the best part about doing these projects and executing these projects is that you will get free access to Edureka Cloud Labs. Now, this is going to be very much beneficial for you because the Cloud Labs has got everything configured, all the softwares that you need, so you don't have to worry about setting the same configuration, setting a VM up by your own in your computer. So you can directly access the Edureka Cloud Labs. It has everything configured and it is as per the industry standards. So even if you get a job as a big data expert, as a big data professional, you will be using the same infrastructure, or you'll be working in the same infrastructure or in the same architecture. So even before becoming one, while learning it, you'll get an experience of what it is like to work in a cloud lab environment, right? So by executing all these projects, you'll get a very good hands-on knowledge about big data and Hadoop, and definitely you'll become a big data expert. Thank you for watching this video. Happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!